Now let's look at the solution to question 3 of paper 1 of the year 2002. This question is testing whether you understand the concept of homogeneity of physical equations. We can test homogeneity of physical equations using base units. A physical equation is said to be homogeneous with respect to base units if the base units on one side of the equal sign is equal to the base unit on the other side of the equal sign. So in this question, we are asked which formula could be correct for the speed v of ocean waves in terms of the density rho of seawater, the acceleration of free fall, the depth h of the ocean, and the wavelength lambda. The starting point is that we must know the base units of certain physical quantities. Like for example, speed has got the base units meters per second. Rho has the base units kilograms per meters cubed because it's density. G is an acceleration, so it has the base units meters per second squared. H has the base units meters, and lambda has the base units meters. In most of the cases, you will find that you will automatically know the base units on one side of that equal sign. For instance, in this question, we know the base units of the left-hand side, which is meters per second. So we want to test whether the base units on the right-hand side is the same. So we start by putting this square root sign there. G has the base units meters per second squared. Lambda has the base units meters, and this one will be meters squared per second squared, and of course there is a square root. This means the square root of meters squared multiplied by the square root of per second squared. And of course the square root of meters squared is meters. The square root of per second squared is per second. And of course, we can see that the base units on the left-hand side is equal to the base units on the right-hand side. That automatically means that the A is the correct answer. Let's look at another one so as to verify that it's not the correct equation. This one has got the base units on the left-hand side of meters per second. The right-hand side has meters per second squared divided by kilograms per meters cubed. And of course, at this point, we are able to tell that since there is a kilogram here, and there is no way that it will cancel with any other base unit here, then it means that the base unit we are going to get on the right-hand side is definitely different from what we have on the left-hand side. However, let's go on and see what we will have. So this one will be meters times meters cubed. We are going to get meters raised to power 4. We're going to have seconds squared there. And there is, of course, the kilogram here. There is the square root sign there. The square root of meters raised to power 4 is meters squared. This one will be per second, and this one will be per kilogram raised to minus a half. So you can definitely see that the base unit on the right-hand side is different from the base units on the left-hand side. But as soon as you get that one of them is working out, this being a multiple choice paper, you simply don't bother with the rest. But for practice purposes, I'd like you to verify that B and C are equations which are not homogeneous as far as base units is concerned.